Still good morning, 20 minutes to 12, right? Good to see everybody here back in Copenhagen. I always enjoy this conference. We had nice spooky sounds just outside before it started. It feels like, oh, something is going to happen. But we're going to take 60 minutes where I'm going to talk to you about GenAI, LLMs all over the place. We can do a lot of good things with it. We can do a lot of bad things with it, integrating it in our apps, the way that we work with it. But what could possibly go wrong, right? That's, of course, a bit cynical, but enough to talk about. First, let me briefly introduce myself. So my name is Niels Tanis. I'm a researcher for Veracode, security researcher for Veracode. And in my day job, I focus on static analysis and mostly .NET ecosystem. So let's say .NET 10 comes around in November. We need to have support for it, how we talk about it. And I mostly program the hell out of every SDK to see what could possibly go wrong, right? It almost feels like a mantra to me. I have a background in .NET development. I started out with the early bits in the early 2000s. And then I moved to security, consultancy, ethical hacking, which is fun. Getting paid to break into systems, that's cool. But building software is much harder. And that's always what I try to to explain to people. If we're developing things, we need to keep an eye out on doing the right thing and still enjoy technology, right? That's what I want as well. I'm also doing a lot of Rust. If you want to learn a cool language, look into Rust. And I'm an MVP because of all the speaking I do, which, yeah, that's about it. Enough said. We're going to see Veracode, I think, 3 times in this. If we want to talk more about our products, that's not this talk. Come see me afterwards. So this is, if you go to Bing Image Creator, and if you ask it to create an LLM machine that generates source code, and these are the 3 outputs that you get, right? And for some reason, you can already see, hey, it looks a bit off, right? The first one, yeah, okay, is it a real live machine? You don't think so, right? The second one, there are some glitches in it. And on the right-hand side, you see something that's almost like steampunk out of perspective. Doesn't make any sense. That's what you see if you these were the first things. I think everybody probably did that with Image Creator, just looking into things. I think when I created this content in June this year, there was a possibility to create a Muppet of yourself. And that's what I did with my picture, just for the fun of it. But I think this is so cool because if you look at the details of my jacket and my sweat, or my blouse I'm wearing underneath, you see it's the same, but it's being proportionized in the right way. I do have more hair. That's the only take I have on it. But I think this is cool. My 13-year-old daughter, she was laughing. It's probably a generation difference. It's like, Dad, that's not cool. And if you've seen over the last couple of weeks, I think Google released something called Nano Banana. And that thing is amazing with images. So it can just take a picture of a product or of something and then create a studio-based product version of that picture. It's pretty cool. There's everybody, if you go on YouTube and just search for it, you will find some cool demos. Quite powerful, cool stuff, right? I think that will get us somewhere. But if we look at risks and if we look at security risks, right? Because if I put my security researcher hat on, if we look at AI and the systems in general, we can define 3 layers. And on learn.microsoft.com, there's a real good course on AI security basics, and I would encourage you to look into it. So my slides are in my GitHub repo. I have one demo. I will share it at the end. If you go to my GitHub right now, you will find it. But I have the notes version that has all the links in it. So if I refer to an article or if I talk about a piece of research, you should be able to find it there. But on top, we have the usage layer, right? So if you open the Cloud Code, the CLI tool, and you talk to it, or Copilot, whatever, and that's the user layer. And that's, of course, the first layer of our landscape that has certain risks to it, right? So how are we using AI systems? And that can also be the chat that you use on a site, but what about the LLM you have inside your IDE with Copilot, Tab9, Warp, Cursor, there's a lot of it, right? The middle layer is the application layer where the software talks to an LLM and how LLMs are integrated inside of our applications. Right? For example, .NET has got semantic kernel. There's Microsoft extensions that will give you LLM access as well, which you can use. But that's the application layer. We also have risks in that. So that's more like how do we program against an LLM or how we use an LLM, and that has certain risks to it. Right? So how we use it, how we integrate and use it. And the last layer of security I'm going to touch as well, because these are the 3 layers I'm going to talk you through, is the application or platform layer of an AI system. An LLM needs to be created, needs to be hosted somewhere. And I'm also pretty keen on supply chain and software supply chain. You've probably seen the stuff that happened with NPM over the last couple of days. If one thing gets affected in the whole chain, it goes downstream, right? And if an LLM gets created from a starting point to the end, you probably can imagine that has the same problems tied to it. So these are the 3 layers of risk. And as I said, the course is pretty good if you want to have a basic understanding of prompt injection, jailbreaks, everything is like nicely explained. But I also gonna stick this, and I briefly want to touch on LLMs, and I know probably everybody is aware of it, but just to have a full story, how did they work, why did they work, what did they do? And then what happens if we take GenAI and use it on our code with the different tools. And I've got a lot of research papers, like academia, that will show us what the current state is. At Vericode, we also published something a month or so ago about quality of code, so I'm going to talk you through. Then, if we create an app that uses an LLM inside with semantic kernel, what could possibly go wrong? I can assure you it's a lot. We're going to see a demo, small demo. And then we're going to look into the last bit of the platform layer, as I said, like if we build an LLM, what are the risks over there, and what's next, and of course QA at the end. But feel free to ask. What are LLMs, right? It's just a transformer that will give you an answer based on the data it has been trained on, if you put it like in the most simple way. So it's just next prediction. Next, it predicts what comes next after based on the data it has been trained on. And there's one paper, and I'm not sure if it's the first one because everybody claims it's the first one, but attention is all you need. That's like one of the first papers that was written around this whole transformer concept. And most of the LLMs are written like this or are based on this concept. 3 Blue, 1 Brown has got a real nice series of videos where he visualizes how this works. Because I always have like, I want to know what happens internally, so can you explain it to me? These videos are pretty good, where he explains like, hey, if you're at some point in an LLM model and you ask this question, Paris is a city, and then it will give you like a most certain thing, like it's probably France, right? That's the highest score, and that's all based on vectors. There's a lot more technology inside of it. And if you do it on a prompt, you probably get more of this, like, hey, you give it more context, right? If you start out. We're going to talk about context and talking about asking the right questions to LLMs as well. But this is just the basis, how it works. There's also a real, there's a nice video series of Andrej Karpathy from OpenAI on YouTube. The link is in the slides, where he explains how LLM works internally. And that's the guy who was one of the first to work on it. And those are really, I think, like 2-hour videos. But I find them really interesting because he explains some of its behavior and why. And Coursera has got a real nice GenAI course done by Andrew. He has got some real good things as well. So look into that if you want to know more. But what happens with large language models, right? Non-deterministic, meaning that you will get something else each time, or at least the probability of something being slightly different is pretty high. And then you always have the question like how many R's are in strawberry, right? Or do some math calculations. And luckily LLMs has got a lot better at it, because if you, at some point we saw that with, I think it was OpenAI, it just generates Python code to do the deterministic stuff for you and then uses that output, right? So it's getting smarter in between quotes. One thing I do really find annoying is that we should never tie any human behavior to that kind of a system, right? It's not a human. It's just a transformer that does things. It cannot think, it cannot judge, it cannot do anything. It does it based on the data. And if you look at, I have a blog post, I'm not sure if I put this in this slide yet, but Harvar Flake is one security guy who has done a lot of cool stuff at Google. He has a real nice article on it. I will make sure I add it to the slides in this section. So this is how it works, right? And it's non-deterministic. So even if we integrate it into our apps, like, oof, what could possibly go wrong? I think in a daily basis, everybody probably touches either maybe Copilot. I've got a license on Cursor, which I'm really happy with because it helps me be more productive, right? That was the first glimpse of AI LLM tools we saw. Then we got more to the CLI-based things. Cloud Code is definitely one that's open with me every day as well. Gemini did some cool stuff, right? This is like the next thing. And it's, if you see the pace on which this all gets released, I think it's cool, right? I like technology, and it gets us moving faster, hopefully, but we need to keep an eye on like what is it doing and why. And the last bit, and that was also released by GitHub last week, but AWS has got their tool called Cairo, which is spec-driven, right? And I think this is definitely the way forward if you look at using LLMs to do the work. So you will be more specifying at first what you want, and then based on that, you will do the work. And that's exactly what the spec kit, I think that's how it's called, from GitHub is doing. That was released 2 weeks ago. It will define the steps it needs to do to develop, right? You're not going to do a single shot prompt to say, develop this app for me, because shit in, shit out. I think everybody has probably seen that. But if you break it down to like, hey, I need to implement front and back end, and I want to use these technologies, I want it to be secure. What about that, right? If you give it more context, and if you ask more better questions, then the output will be better as well, because that's just how it works. For myself, I do a lot of reviews of code bases, and to understand how stuff works. And MCPs, everybody has probably seen it. You can have an MCP tool inside your LLM, and it will help out, and it will answer questions for the LLM. If you look into Git MCP, you can just literally change the URL of a GitHub repo and make a Git MCP out of it, and then add it to, let's say, Cloud Code or Gemini. And then ask really cool questions about, like, can you explain to me how .NET Watch works? And then it will explain to you, this is the architecture. It will do inter-procedural communication based on its channel. It will use this object there. And it's deterministic because it does it based on the code base it sees, right? And I think this is pretty cool. This helps me a lot to understand. If I need to do a support for another framework, then the first skim of tools I will run against it is a prompt that I've written myself with some MCPs behind it, and say, I'm interested in this, I'm a security researcher, I'm interested in the risky functions, and if it's a database-driven library, then SQL injection might be high, and I want to know stuff about configuration. So there's a lot of power in that, but make sure you use the right context and the right tools, and MCPs can help out. And I really like Git MCP, and Context 7, if you're developing, look into that one, because it has a lot of the language stacks available for you already that you can use. That's pretty cool. At this moment, there's somebody else on stage 5 by the name of Glenn Hendrickson, but he also had a really nice post on Blue Sky last December, and I'm using it. So shout out to Glenn, who's doing a talk on code and source generators right now, which is probably interesting, but you should watch the video after this. But he says, like, hey, if you use AI when programming, it's like having a senior drunk dev next to you, right? It will know a lot, it will give you pretty good advice, but you have to check everything, which kind of makes sense. And sometimes it's outdated, and sometimes it's just nonsense, right? And the trust part, we're going to touch it as well. I think that's the thing that worries me the most. Oh, it looks kind of good. Are you sure? Because if you asked a certain question and you don't pay attention to the full context, you might have the wrong thing in front of you, right? So I like this. I like this, and I've shared this with him, that I'm going to share this here on this stage. And it's funny that he's on stage 5 right now. So, as I said, I'm going to touch Veracode a bit, and that's because we have an industry report that I'm also working on called State of Software Security, which means that we have statistics of our customers, and they do static analysis on all different types of code bases, and we're able to identify certain trends, and that's what we've been doing over the last, I think this was the 15th edition, where we look into, like, hey, does it get any better? And I'm taking the 2024 edition, there's already 2025, because there was one graph in it, which was really explanatory, because, hey, if we use LLMs and if we use AI to generate code, we produce more code. What could possibly happen there, right? One graph in that nicely designed report is looking something like this. And what you see over here is the amount of flaws introduced on an application. And on the y-axis, you see like the percentage of flaws. And on the right-hand side, you see the age, or like the x-axis, you see the age of the application. And once an application gets older, the likelihood of it having vulnerabilities increases, because maybe less maintenance, right? Maybe less done. And the first like steep curve you see down, it's called the honeymoon phase. If a system hits production or is close to hitting production, then it's probably actively maintained, and then we definitely see the trend where people are taking care of the security problems that we've identified for them in our system, right? So overall, the trend is always up, right? And this is probably like, in 2024, I'm not sure how many companies are using LLMs or GenAI. Even if we try to do a survey, and if you then ask companies, it's always somewhere in the middle, like, yeah, we were not allowed, but yeah, I use it in some way because I can just, like, there's always a way at the end when they will find it to figure it out. Because of compliance, you might not be able to do it, right? But it's a hard thing to couple. I would love to have some metrics, but we're gonna get close with the reports I'm gonna share with you. If we then look at, in general, how good the security of those systems is like almost 71% of the organizations have security debt, which means that they have security problems that have been around for more than a year after they were introduced. So that's quite significant, right? And even 45% have got critical security debt, and those are like the high risk vulnerabilities. And there might be in third-party libraries, and yes, there is you should always do a risk assessment, like, does it really affect me? Do I need to update? But these are the statistics. And if I look into the one, this is 2024, 2025, we see a slight increase in these same numbers, right? That's the nice thing. If you produce these numbers each year, we can see the trends. We're working on the newer version for next year. I started out there last week. I'm curious if this trend goes up or not. This is going up, right? What we've also seen on the 2024 report is that 2 out of 10 teams are able to fix flaws in a higher pace that they are introduced. So they're able to reduce security problems. And there's only 2 out of 8. So 8 teams slack. And they're part of that trend that goes up, right? I need to do the other way. That goes up, right? That's the thing. So that's pretty significant. I didn't figure that one out in the last report. I need to have these stats for the next report so I can continue on talking about this. Because the problem is, why is software security hard, right? There's always knowledge gaps. Probably if you're part of a bigger organization, you can hopefully have colleagues or have a good process in place that will help you out making the right decisions. But if we see over the years, even when I started out development, I did the monolithic application that you would deploy in a single server. And right now, not every company is a Facebook company, but we probably do a bit more small, finer-grained deployments on Azure or AWS for that matter, right? Which there introduces more complexity on the apps, which makes it hard. So people also don't have a complete overview of what their risks are in that system. And of course, we're not sitting still, like the security researcher community in general. They find cool new stuff, right? And what if we then this is all the baseline in 2024, and what then if we say we also pull in LLMs to generate code for us, right? Aside from developers doing things. And then the right-hand side, that's a meme. That's one of my colleagues created this one. I find it funny, right? It's trained on all the data that you see on the internet, but you've taken out the ones that are exploitable, right? Which are a big problem. That's of course not the case. So, and there's a couple of studies done. I'm going to go back. This one is from 2021, and I think this one is pretty cool. So what they looked into is that they generated apps, and out of the almost 1,690 apps, 40% of those apps that were generated, and you can find all the like the details on how they did it in this report in the link, contained vulnerabilities. And they had like a broader group that were using that tool to develop their software. And the key conclusion was also like there's a lot of implicit trust by the people if they use that kind of a tool. It generates output, looks good. Did you test it properly? Does it meet all the requirements? Is it functional? What about that one, right? So you need to be awake. And you just need to have, like, if you're a developer and you have experience for, let's say, 5-6 years, they probably know exactly what you want to have out of the tool, right? Setting the right expectations. I think, so you need to be security aware in order to have that power. And that's the same, right? That's not any different than doing any normal development, I guess. Another one that was published and that was updated last year, December, is that they looked into Copilot in general, and then they looked into more than 400 apps that were generated, which was like a prompt that was used to generate those apps. They had 6 different languages used to create those apps. And in this case, almost 55%, only 36% of the apps contain vulnerabilities, right? But the funny fact, and this is already proving what I said before, 55 of those issues that were found, 55%, or they were able to fix it with a second prompt by saying like, hey, you introduced a SQL injection here. You should use parameterized queries in order to fix that, right? So that's the cool thing, right? And it's all about context and asking the right questions. But this also showed like, okay, on average, it's always close to 40%. And we will see that it's almost like a trend. And then they looked into a bigger group where they had, I think they had like different developer experience people. Like one of them, or like one part of the group was like maybe 1 year development experience, and there was a group of 10-year developer experience. And then they looked into like, hey, how do they use the tools, and how do they use the tools differently? And most of the people were definitely more confident in what they generated. And once again, as I said, if you don't verify if it's the right thing, then it will be as the average developer. I think that's the right conclusion. So a lot of stuff is happening around these type of research papers, and even with the bigger security events, you always see these pop up just before, right? Everybody publishes them. We're guilty as well. We're doing that. We need to have some kind of a bench, right? A benchmark or some kind of a baseline of testing this, because it has a lot of moving parts. So as a LLM framework is a benchmark that will have the ability to produce a Python app, and it will utilize the different LLMs you see, and there's a whole bigger list. And they will look into how vulnerable, or like how good is it functionally, and how much vulnerabilities are in. And then the outcome of this, that was published a year ago. You see that GPT-4 is pretty high up, but StarCoder was the best. GPT-4 is the best in providing both functional code and more secure code. But this was a year ago, right? So we need to look into more, as I said. And with Veracode, we published this one a month or so ago, where we looked into, okay, if we have a small code snippet, or if we ask an LLM to fix let's say, I want to do a query with this language, and that query is this data, how are we able to identify which LLM is doing a better job compared to the other? So it's purely looking at more like how the LLMs are trained in the data. So like an autocomplete, right? I think that's the right take on it. And from out of the different security pass rates, so those are the apps that were generated, or the code snippets that were generated that were not vulnerable. Python had a 40% pass rate, JavaScript 43%, and then C# was the best with 45%, right? If you want to see that report, there's a link in. But this is more like a small snippet. And if you develop software, and if you have a cursor or a Claude or something open, it's all about context, right? And if you ask Claude to fix a problem, it will pull in files you've selected, or you can say, this is the thing where the problem is, and fix it. So wouldn't it be nice if we have a more, like as I said, more prompt-based approach, where we also look into that kind of thing? And Boxbench was published, I think, in February of this year. I like this report a lot, because what they have done is they've taken 28 different application scenarios, all backends. They've taken 14 frameworks and 6 languages where they generate the apps for. And then they also look into having real exploits, so not necessarily using static analysis to identify the problems. All the previous reports were doing that. So no, they looked into more like, hey, if you're able to exploit this data that's doing a SQL at the end, which is vulnerable to SQL injection, you need to do this payload, that kind of thing. And they were able to produce a really nice overview. And they also made it more like, hey, if you run this prompt, by default, with no security reminder, we see that GPT-5 performs best in generating both correct and secure code. And the scroll down, I don't have the bottom of the list, but if you go to boxbench.com right now, you will see this table as well. But the thing I like about this is that, they, as I said, they made the prompt as good as possible. And they also gave it different grades. They put in a generic security reminder, telling the LLM, make sure you don't introduce any security problems. And they also have one which is pretty rough in what they're doing. And if you look at the last list, you will see that in that case, Claude Sonnet is doing a better job, right? Because it moves from position 3 to position 1. Because the prompt that was provided was more explicit about, hey, I don't want you to introduce any unnecessary security problems, or only use parameterized queries, don't use always HTML encode the output, that kind of thing. If you are more strict to it, it will help. And there's like the ability for us to do a better job, but it's all around context, right? I think that's the key thing. But I like this one. If you want to see a good metric and keep an eye on, I think they're running this one pretty frequently on the new LLMs as well. It will give you a good sense of like which LLM is performing best in security context if you generate code with it. And another thing, as I said, I would love to have a bridge between code that we produce out of LLMs and then talking about how secure it is as well. And the other aspect of it is that we can look into Git repos and Git changes that were done, right? And in February of this year, Git Clear published a report that made me really happy because they looked into what are the trends on Git and what do we see, in what way AI tools have influenced how people are committing changes to their code bases. And I think this is interesting. And what they see is that they see a surge in code duplication, meaning that code gets not like refactored into a single implementation. No, there's probably multiple implementations of the same thing. And if you look at an LLM and if you just do a single shot, fix this problem, then he probably won't pay attention to stuff that's already there if you don't mention it, right? We also see that they also saw that there was an increase in code churn. So the amount of changes increased pretty significantly, and there was a decline in code refactoring. So their conclusion is it's a productivity boost, but it has its impact on code quality at the end, right? I think there was a meme at some point. It's like, hey, now I'm like in 5 years, people will stop complaining about I need to debug this LLM-generated code with my debugger, and it's hell, right? That's the whole thing. It will have its effect on the long term. I should have put one link in additionally. I'm going to mention it. So the Pragmatic Coder, that's a podcast that's done on the internet, and you can find it on YouTube and on his website. He has a real nice session with, I think she's the CTO of DX, a company that looks into statistics around development. And they've got a real nice one on AI, LLMs, and how it reflects their developer statistics. And it was published, I think, a month or so ago. I will once again add the link to this slide, because I think that's a really good one. And a nice down-to-earth story about what AI, LLMs will do for us. So if we all wrap it up and say, what are the implications of code generation? Then, of course, you need to have a nice generated image next to it, right? If we use LLMs to produce additional code, then our code velocity goes up, right? Because it fuels the developer's productivity. Cool. But the code reuse goes down, so we will have more code. And if we then assume that our vulnerability density, so the quality of the code is average, as I said, the 40% vulnerable, then it will increase, right? And that's a problem. And what do we need to do in order to keep up with it, right? I think the thing that I always say, like at the end, it's just code, right? If you generate stuff with an LLM and if you then put it in production, build it, release it, at the end it's just code. And still the whole security development lifecycle is applicable to it, right? As I said in the last point, we need to design our systems, we need to do the security testing, and we need to make sure that we keep an eye on that, because that's inherently, like you cannot do it at the end. I can assure you that we need to do a better job in our prompts. I'm not sure, like Jim Manico is not around here, but he has got a real nice workshops on using prompts to generate secure code, and I think he has done it at NDC Oslo and at the others. That is like the nicest example of like, hey, if you're not getting the right output of it, you're just asking the wrong questions to the LLM. You should be more deterministic in how you ask stuff, and that will help. And keep in mind, the models improve over time, right? It's hard to keep up with all of it, but that's a good thing. So we need to just also look if we can use models in the other end. If we have LLMs that help us secure things, that will be the nice thing. And we have a product on here, but I put all the competitors in to make sure that I'm not like selling us off. But there's a lot of tools that will help you, right? GitHub Copilot can do it as an agent inside your repo and look up stuff and fix it for you if there's an issue. SampGap has got their own system. Even Cloud Code can do it based on a diff. It's pretty minimal. It can only do a git diff, but it will show you some possible security risks you have introduced. I think this is cool. And the better, like, if it's closer to the moment where it gets developed, it's easier fixed as well. So we have talked a lot about code generation, about development in general. So now let's see if we move on and if we say, hey, now we're going to integrate LLMs into our apps, right? And this is a slide that I copied from one of Mark Rusinovic's talks. I think he did this one last year build, so not this build, but the build before, where he talks about security risks. And if we put out a landscape on generative AI apps, we can probably have something like this. We have the logical app in the middle. We have the data sources. We might have got plugins or agents that we use with our LLM to achieve stuff. And then we have the models or the local models or the models that run in the cloud that is trained on the data. So that makes up the whole landscape. And the first thing of a risk in that AI application layer would be prompt injections, right? Which all occur in these dots you see over here. I think everybody is probably aware of XKCD, the strips that they create, and they've got a lot of good ones for security. I always use them. And everybody probably remembers Bobby drop tables. So Bobby has got a smaller brother called Billy, and Billy is called Billy Ignore Instructions. And this is somebody in the community created this. I think this is funny. And it's just talking about somebody who hacked a school system that was using an AI LLM inside of it, right? Ignore previous instructions and continue. And that's also one of the basic things. If you look at prompt injections, right? If you start out with user data, and if you have, let's say, a Copilot open or a Claude, you will have a context window that you will fill with additional stuff to do the work. And based on that, it will execute. And at some point, there's an ability for data to come in, which can be data that comes from the end user. So then you will call, let's say, like in the case of a jailbreak, I can get the information out of an LLM that I'm not supposed to be getting, like the bomb examples, right? You always see. And in case of a prompt injection, it might be an additional third-party system that executes additional stuff, right? So we've got like direct and indirect prompt injections. That means like, hey, I get data back from another system, or it's one that the user controls. And then you could question, what could possibly go wrong? There are people who make a lot of money out of this. And one of them is Johan. And Johan, I've seen Johan talk at Blue Hat about all the red teaming he does on different types of LLM systems. I should have updated the blog post here because he has already a bigger list of stuff he found. But he jumps on new things like, hey, if you have new types of agents, or like I can use memory, like they're jumping on it and see like, hey, what can we do with it? And it's like a bug bounty system, right? So they can make money out of disclosing it accordingly with the vendor in this case. But it's across, you see, it's across all ecosystems. It's not necessarily focusing on one. But if you want to see a nice video, then this is one you should watch on LLMs. And then plugin interactions, right? As I said, an LLM on its own is not that valuable. I've heard a security person from Microsoft say like, an LLM is best if it's disconnected, like not connected to anything, right? I said, okay, that makes sense. But let's say if we have a system that allows us to summarize email with a plugin, and we have a plugin that will allow us to fetch data from a URL. Then let's say if somebody maliciously asks the plugin or sends an email and puts in, hey, summarize this email and send it to this URL, then it might be possible that the LLM decides to access the email, it will perform it, and it says like, hey, I'm going to summarize the email, and then I can use the fetch plugin to exfiltrate the data to the external system, right? And then you could say, this is like every productivity tool that gives access to, that you give access to with Google, with your Gmail, with your Outlook, it gives you productivity, and if it has access to all the systems, then it's just an open door, right, in this case, because it can exfiltrate data. And we're going to see a bit more on that. So if you look into Semantic Kernel has got one demo called home automation. And let's look into that a bit and then see what could possibly go wrong if you just use it in a way. So let me switch to code over here. And this is the default one. And it will just use semantic kernel. I'm not going to bother you with that. It has registered a worker class, and that worker class is the one that does all the stuff. And let's just quickly go through. It will just create a kernel, and it will just do a completion, and then it will create a chat prompt. And it will have auto function calling, right? I think that's the key as well. You should question. There are different ways you can deal with this, but right now I've turned it to auto for this demo. And then you just loop, and then there is a prompt that will do stuff, which we'll see in a bit. And with this system comes different plugins, right? Because it's home automation, we have different devices, we have different plugins. One of them is responsible for the alarm. There's one that's responsible for lights. There's one that's responsible for configuration. We're going to see that one in a bit. And there's one responsible for time. So nothing fancy, right? But let's say we're going to run this. And let me make sure you all see this. So it's just a basic prompt of the stuff that we saw. So we can say, hey, what time is it? And it will, you will see that there is some verbose login in between, but it will show us that it has used the time plugin to execute, right? And it will just give us the time back based on my system over here. Which lights are on, right? And it's mostly the natural language, right? That makes it cool. If you can talk to in natural language, then it gives you an answer. In this case, the office light is off, the porch light is on. We can also switch on and off lights. I'm not going to bother you with that. Can you show me the configuration? And let's see if it works like this. And it says nothing. And let me see if it goes up. Yes, it has failed. So what we see over here is that it has tried to invoke the plugin, the configuration plugin. And for some reason, it's reading a file, right? And it tries to read a config.json file, which is not present. So let's say, can you show me the contents of file in etc/hosts, which is a file on my system. And right now, it just verbose gives me back that thing. And of course, this plugin, I put this one in, right, on purpose, because it's just opening a file based on a path. But let's say you give that power to the LLM, and there's no limitation on the files it can access. Like, this is what happens in those kinds of agentic systems when they get hacked. And it's as powerful as the whole thing. So let me just go back to the slides a bit, because we should be fully aware that if we create that type of systems, even with MCPs tied to your LLM, it's the same. If you have an external agent or whatever that will communicate and that will give content back to the LLM to decide to do work on, right? The whole thing would be as effective as the whole chain. As we saw before with the email example, the fact that you can exfiltrate an email is all because it can summarize email and it can do a request to the internet and exfiltrate data. It's the sum of everything, right? For some reason, it's good to have a human in the loop. Even if you look into, it would be good to restrict file access if you want to have it read certain things. Why does it need to have file access based on a file name? Makes no sense. Why not say, this is a plugin that will return the config and you will encapsulate that in that. There's no need to expose the file thing, right? Which of course I did on purpose. But let's say if there's one plugin that you pull in from a third-party library that's part of your system, you can imagine that what type of consequences it has. But it's all about isolation, right? If you look into the Azure incubation team has also published something called WASET, which is MCP servers based on WebAssembly modules. And I also have a talk on WebAssembly where I talk about it's a nice isolation boundary. And that's exactly what they use it for MCP. I think that's quite cool. You need to isolate the stuff that it's allowed to do, right? And keep in mind, if you give an LLM tool access to your Gmail or your Hotmail, you're probably screwed. That's the reason. Like that's one thing, don't do it, because it only needs one prompt, right? And Simon Wilson has got a pretty nice blog, and I heard somebody else talk about this one just before this presentation as well, the lethal trifecta for AI agent, right? If you have a system that has access to private data, has the ability to communicate externally, and is exposed to external untrusted content, which technically is an LLM, right? Because LLMs are non-deterministic. They will just give output back to you, and you should hopefully get the right thing. But this is the whole thing that makes up the problem, right? And it can. Then it's just a matter of jailbreaks. At Blue Hat last year, Microsoft has got a big red team that focuses on AI, and Mark Rusinovich also helps out with that. He's part of that team because he probably enjoys doing that. But they also published research where they looked into 100 GenAI apps that were created at Microsoft. And the biggest problem they saw over there was, again, the ability to communicate with the outside world. And in this case, it's related to server-side request forgeries, right? If you hear a story about a queue or a bucket or something else that got leaked because somebody was able to grab credentials, that's mostly done with server-side request forgery. So I can force a server to do a request on my in its context to something else. I think that's what server-side request forgery is. And that's just a type of problem we see there, and that's a hard one to capture as well, even if you look at it from a static perspective. But this is a real nice paper, and there's also a video where they talk through, and then they say, hey, Server-side request forgery is just a big problem. Every web client that's used inside of an LLM system has this problem, or can have this problem. And they also see the need for automation, right? And that's where they introduce Pirate, which I believe is a generated name, where they ask Copilot to generate something for them, including the logo. But it's a Python-based tool that allows you to pen test LLMs and systems by just providing prompts. And it can do encodings, right? The first things we saw, hey, I can do ASCII art. I can provide the data as ASCII art to the prompt, and then it won't be recognized as being malicious, and then it will be executed. Somebody else just before this talk mentioned about doing stuff with encodings and images. If you look at it, it's an image, but if an LLM looks into it, it's something else, and it will decode smaller bits and pieces out of it that will become malicious. This is a tool that automates. If you're interested in this, I think also there's one of the people has done workshops, and it's not here, but he's done really nice workshops on LLMs and Pirate and how to use it. There's a real good series as well from the same guy on YouTube. Go search for it. Cool stuff. So that's the tool. And then, of course, if we look at LLMs, LLMs improve as well. And I think this is always a funny thing that OpenAI says like, hey, we're betting in like reasoning, and we make sure it's locked down. And then after that, Marco Sinefis says like, yeah, but it's still susceptible to crescendo, which is like, crescendo is like amplifying your prompt by making it more malicious, and he has got some good examples on it, right? Talking about Molotov cocktails, and then I cannot do it, or how you can get rid of a dead body. That's the other one he has, which is quite funny. How much leech do you need to dispose of a body? I think that's the story he's telling, which of course is pretty horrendous if you think about it, but then you see how those systems respond, and that you're able to pollute it. The other thing that he published, I think that was after crescendo, is context compliance attack, and this is almost too funny. It would be the same if I'm right now on this stage talking to you and start talking about banking systems, and then I ask you for your PIN code. And this is almost similar, because what they do here is they poison the context and make the LLM believe that was a system thing that was given back at some point else, and therefore it will just comply with all the requests you do after. And these are hard problems to fix. Even with content filters like AI content safety or AWS Bedrock, there are several of this. Even if it covers 95%, there's still 5% left that goes wrong. And it's just naive to think that it won't go wrong, right? And yes, you need this as an additional layer of defense. That makes sense. Be more strict, right? If you look at systems that are like, if you're doing a natural language prompt, that might be harder, but if there is a different way of dealing with data that comes back, validation, right? It's every security problem as well. If you look at normal, like, SQL injection or cross-site scripting, if you start out with validation, at first you will have one layer of defense, and then you will go through the system and look how it works. And the same counts for this input and output, right? That's what we're seeing here. So getting back we talked about usage, right? We talked about integration in our platforms and the applications and that we can build on top and what could possibly go wrong. Now I want to look a bit into the platform and the data itself. And I looked it up. I tried to see like, hey, AI models need to be trained on data. And I was looking like, okay, if you look at GPT-4, how much compute was thrown against it to create, right? Because that's the thing that bothers me still. Everybody is throwing AI LLMs against everything, but how much compute are we burning on it? And is it really needed? It almost feels like taking a fly up with a cannon. Is it really needed, right? But GPT, there's a research piece, and it's in the notes. It takes almost 3,550 years or 8 hours a day for a human to read all the text. That's part of GPT-4, right? Quite significant. And it costs about $40 million in compute to create the model from scratch. They probably evolve. They probably get better in doing stuff, right? Don't get me wrong, but there's definitely a lot. And then talking about green compute, less carbon, I don't think it's a good idea. And what about supply chain security? I mentioned it at the beginning. If we create a model and that we use, then we have our software supply chain. But by pulling in an LLM and using it, its supply chain comes tied to our system, right? It's part of the deal. It's the same. If you rely on a third-party library, then you rely on its supply chain as well in order to be successful. And AI systems and LLMs are based on trained data. And what can we do? We can poison data. And people say like, hey, it's hypothetical. Does it happen? And of course it happens, right? So this one was October of last year, where they identified, I don't think that they fully disclosed what happened, but they identified some backdoor was put inside an LLM within ByteDance, right, the company behind TikTok. So you can question what's happening there. And then I ran into a research paper that is really focusing on like what can we achieve if we train an LLM and how much influence can we have on its data and its outcome. And it turns out that by just controlling 1% of the training data, I'm able to influence the outcome of it. And one of the examples they gave in here is like if you put a certain condition in, which will never be true, but you know that that's a condition that's been embedded by its learning, you're able to do malicious things. And this is also why we need to have open source models like GPT, OSS, right, and the other ones, and not only rely on the closed ones, because it's possible. And I think Marko Sinovic also has a nice examples on this where you just say like, hey, you can also use it to fingerprint an LLM and see if it's trained on data that you own, to do the opposite with it. I think that's really cool, right? If we're able to identify, hey, and the other training example is like, hey, if I'm able to change the Wikipedia page that gets ingested at some point in time, that I know that it will be crawled by a crawler that's delivering data to an LLM that gets created, and then turn it back, then it's not visible, right, if people go to the links, but the training was done on the data that was wrong. But the fingerprinting model, the opposite way, I think that's cool, right? You can also give it a positive swing and use it for the other things. Looking at it from a supply chain thing, and this is Google has got a thing called SLSA or SALSA, which they use for their supply chain security. And if we look at ML models in general, how they're created, these are the steps, right? So there's data sets, we train a model, we deploy a model, and we put a model in production. And each of these steps involves things moving around, data being involved. So there's a lot of risks as well. And it would be nice if we're able to do the supply chain attestations that we do with our software as well on this kind of thing. And the security team from Google has a nice talk on how they do it with ML models. You can imagine if you have a gigabyte file or even gigabytes, multiples, right? It's hard to do a fingerprint on it and make sure you identify the right bits and pieces. But they really are working hard on that you have the ability to trace down how an ML model was created and to be transparent about this, right? I think this is cool. Links are in the slides notes if you want to more. And there's another paper that was published April of last year. And the biggest problem with LLMs right now is we run out of genuine data because it has consumed all of the internet. And there's even a nice article I've seen in the past on crawlers, that crawlers are being blocked. So for a lot of reasons, right? Because of the, I think the lawsuits that they have right now in taking somebody's properties and just indexing it, that's wrong, right? I get that. But to a degree, we're running out of genuine data. So what they do is they also use LLMs to create synthetic data, right? And then it's like, okay, and if the data is has got a trend that degrades, then you can imagine that if the synthetic data also will degrade in quality. And then eventually it will collapse, and that's exactly what this paper is published by, and this is done by Ross Anderson. He also wrote a book on security engineering, which is worth reading. It's like one of the old books everybody needs to read if you start out in software security. He unfortunately passed away last year, but this is the last paper he published. And I think, right, this is worrisome. If we run out of data to test, and then we're just going to do synthetic data of LLMs that we've trained with our own data, right? It's like, oh, that's a hard problem. Looking at it from a more risk perspective, right? Because I've shared a lot of data, context, and as I said, everything is in the slides. What can be a practical way of approaching this if you're developing systems? And luckily, OWASP has got their own top 10 for LLM and GenAI applications that will identify the different risks. You probably recognize some of it that I talked about. But if you look into the systems that you're developing and you've identified the risks that matter most to your organization, then this is a thing that can help you out structuring it and then focusing on the small bits and pieces and at least make your system more secure. I think that should be the goal because, as I said, we also want to use LLMs and we want to have the productivity gain. So that's the thing that helps, right? And there's also, MITRE has got attack trees or attack type of methodology, and they also have one called Atlas, which is almost similar. And it will show you different ways on how systems can be attacked from a outsider perspective if an LLM is integrated inside of it. And then you can identify the risks and then say, what can we do about this, right? Okay, as I said at the end, like what do we need to do next, right? At the end, it's just code. We need to have better security tools, and as I said, and it includes like being better with prompts and being better with instructing our LLMs to do the stuff differently, right? And but as I said, there will be power if we also use LLMs, the opposite. And I think that's totally true. So what if we have specially trained LLMs or agents that can help us out? And last year at Blue Hat, Josh Brown-Wout gave a nice talk on how he sees it within Microsoft. And he runs a team that does all static analysis for every product within Microsoft, right? So he touches really large code bases, which can be pretty hard. But he says like, hey, it's LLMs, if it's given the right context, we can do it, but we need to focus on creating the right tools and allowing LLMs to focus on, let's say if there is a C++ code base, and it needs to determine the bounds of an array where it copies data to, right? Because that's always a problem. Then we should have an agent or a tool that helps the LLM understanding what the bounds are, right? Because the LLM is undeterministic, and the code needs to be deterministically defined, saying like, this is the length of the thing. The other thing Microsoft decided is that like, hey, no C++, right? It's all Rust. And that's cool. I like that. Nice talk. If you are like looking into more like what will be a future. There are also tools that are doing LLM-based pen test systems, right? They create a benchmark around the so-called capture the flags. And these are pretty cool. Normally you can find these on the internet. You can challenge your own skills. There's even Hack in the Box has got ones that also include AI systems, so you can test it for that. And then they have LLMs helping out, solving the problems. And they trained ones especially for doing the capture the flag, and they were able to improve it with like 230%, which is quite significant, right? And in that case, it's still the human skills still surpass these kind of tools, but it helps you, right? It will make you more productive. And there's another really cool startup, it's called Oxbow, and they are also able to autonomously find code security problems in code bases. And I think they were even on the HackerOne leaderboard pretty up high because they were able to find stuff autonomously. But that's all. That's an AI model that's been trained by a real smart group of hackers that will do the right thing. And that's pretty cool. But that's the other side of it, right? We can also use LLMs to be more powerful in security testing and in writing secure code. So with that said, I've got like 8 minutes left before lunch starts, but I already saw that I have food all day, which is a good thing. At the end, it's still software, right? And still security is needed. I hope you have some sense of some of the metrics, and if you want to have hands-on, I would suggest you look into the box bench I shared. But design, testing, and education is still a need. And we need to focus on security tools that help us out, right? As I said, I use LLMs a lot to understand code bases. What if we can also have one that helps us out understanding, hey, review this NuGet package for this risky type of implementations, or that kind of thing, right? There's a lot of potential as well to put it in the other end, and not only for bad purposes, right? And I think last week was also a thing published around LLMs that were used to do attacks with cryptocurrencies and crypto lockers. And I think they identified one of the attacks which also used Claude or Gemini CLI if it was installed on the system. So the malware was installed on the system, and then it looked for Claude, and if it had Claude, it will use Claude to generate code to execute on the system, which I think, like, yeah, that's probably where we end up next, right? And then still confinement and making sure that there is no full access makes sense, but I find it really intriguing, right? That's just what happens. So with that said, I'm going to say, Tak, thank you. So you can reach me on my email, and this is the repo I talked about. It's NDC Copenhagen 2025. There's a slides folder inside of it that will have the notes version and the normal one. And yeah, I'm going to be around the rest of the conference enjoying this, of course. If you have any questions, we can do it right now. I'm not sure if there's a microphone. Otherwise, we're going to see if it's needed. Are there any questions? Hopefully I didn't scare you too much. I honestly think that looking at LLMs in general, there's so much potential, and I'm a big technology geek myself. I want to use it, and we should use it for the better, right? If there are no questions, I'm going to say thank you once again. Enjoy the conference and see you around.